So please turn your phone in silent so we're not affecting the talk. And welcome to the first practice talk of as a side event of Mind Machine exhibition as a part of Vietnam Festival of Creativity and Design organized by RMIT Việt Nam. And as a quick introduce, I will be a moderator today. I'm Miên. I'm a visual artist, one artist of this show, but my background is in surface textile. I graduated in University of the Art London, and I have a small brand called Collective Son, where we focusing on trying to make sustainable and modern living with like Vietnamese identities. And let me introduce our speaker today, Ms. Donna Cleveland. She's associate professor in RMIT Việt Nam. And she's a deputy dean of School of Communication and Design at RMIT. And her research is in the field of sustainable design, articulate fashion, and textile thinking and system. Her practice is engaged with the issue of materiality, making, and resilience across areas of art, design, and creative technology. And today, I will let Donna sharing about her experiment and practice.
Nice, thank you so much. Great introduction. So we've got a fantastic display of student work out in the main room there, and most of what we teach in our classes is often inspired by what we do in our research. So today we're going to share with you a little bit about what we do in our research and how that inspires our teaching, and how that results in amazing community impact. And these amazing materials that you'll see out there and that we can engage with after the talk. So our research is titled Material Futures, and it's really around looking at the use of growing kombucha or biomaterials to help us reduce plastic waste and other textiles waste into landfill. And at the same time, we do two other really important things. One is we can close the loop on food waste. So we use food waste to feed our new materials or to dye our new materials. And also we work with communities in Vietnam to see how we can help them to collaborate with them to involve them to improve their livelihoods in the areas that they're in. So at the moment we're working really closely in the Quang Nam province around sustainable orientated innovation. So this presentation is a little bit about some of that research, a very short little snippet about the research. But we started in 2021 looking at how we could grow the biomaterials, and in particular the kombucha leather from locally sourced food sources in Vietnam. So the images that you're seeing here are some of our samples. And they are literally grown in the process of making the drink kombucha. So does everybody like drinking kombucha? Yeah, lots of nodding, me too. So in the process of brewing kombucha, we, like this big jar here, it makes a funny layer on the top of it. It actually spins the layer of bacteria cellulose, and it's this combination of bacteria, but good bacteria like the ones you like, and good yeasts. And they make a symbiotic culture of bacteria and yeast, and they grow on the top of the liquid. And that happens when we make kombucha. But what we're interested in is how we can grow that using local food sources, sugars and teas and things, and how we can harvest that top cellulose in ways that we might look at drying it and tanning it and using it for alternatives to leathers and plastics in Vietnam. So what we're really interested in is the biomaterial side of it. And that's because lots of things say they're bio-based, or they're biodegradable, or they're biocompostable. All these different terms we now use for materials. But a lot of the time they need a very specific environment to be in to actually compost or actually decompose. And our biomaterials are wonderful because they do truly biodegrade in any environment, so they don't need a compost environment to do that. And they also biodegrade very quickly. So what we're really interested in is, there's lots of different biomaterials, and some people talk about them as sort of crafted materials or grown materials. And the crafted materials you'll also see here in our display from the students. That includes bioplastics made with silicons or resins or foams. There's also sorts of fish leathers, fruit leathers. That's like pineapple leather. I'm sure you've all seen that. I think it's all over social media about people's pineapple leather. Algae leather, leathers grown from coconut. So they're really crafted materials. And then on the other side there, you've got the microbial leathers, fungi leathers and other sorts of leathers. And we're really interested in that microbial leather part, where we use the good bacterias and the good yeast to grow new materials. So other ways that people talk about the biomaterials is through their applications. So sometimes they talk about them as being relatable, like plastics or bricks or yarns. So, and that's because, for want of another terminology, we look back at what we've done in history. We look at the technologies that we used to use, and so we talk about them as bioplastics, but we say they're still yarns, or they're spider silk yarns, or they're leathers, and I think that that's one of the exciting parts about biomaterials, is actually that they have a lot of potential. And sometimes when we categorize them into applications, or we categorize them into raw materials and made materials, we sometimes lose the potential of the materials. So I'm really interested in us thinking of them as biomaterials, understanding what we've grown them from and how we can alter the characteristics of the materials depending on what we grow them with. But we also don't want to close off and say they're a yarn, or they're a leather, or they're a replacement for plastics, because these materials have a much bigger potential than that. So I think this image really captures what I'm trying to do, but plastic is a substance that the world just can't digest. I think we already know that, and I'm not here to preach to you about plastic, but plastic is a huge problem globally, and it's definitely a problem in Vietnam. And Vietnam is one of the largest polluters of plastic in the world. And so when I moved from New Zealand to here, it was one of my goals and aims was to help Vietnam become plastic free. So plastic, well, that's not a very good slide in PowerPoint. Plastic never goes away. It attracts other pollutants. It piles up in our environment. It costs billions of dollars to abate, and we know big companies that spend a lot of money looking at how they can abate their plastic wastes. And then we have these sort of new leather or leather lookalikes. Like I say, I hate to categorize them into areas instead of just seeing their potential, but we sort of have to understand them in some way. And so it's this bottom right-hand corner that we're interested in, these microbial leathers that bubble and toil and trouble in the mixture and grow. So kombucha is a widely used and fermented drink. The name kombucha actually derives from the Korean physician Dr. Kombu, and the mixture of that word and cha, which obviously in Vietnamese as well means tea. And he figured out that he could, in the process of fermenting tea, make this drink kombucha. So that's where the drink originated from. So why should we care about it? Well, all of these other products, harm animals, harm humans, harm our biosphere. The plastic, in particular, is, detrimental in our oceans. As I said before, unfortunately, Vietnam's the third largest per capita waste producer in Asia Pacific. And plastic consumption has risen here substantially over the years. And I think this is partly due to a fantastic rising economy. So that's a good problem to have. That's an amazing problem. But with that comes more people, more imported goods, more things that are covered in plastic, and more tons, of course, of plastic waste that we need to dispose of. That's a global issue. So why we undertook this research more specifically was to find out the opportunities for Vietnam for the local bioeconomy. So what could we feed it with that's local to Vietnam that might change the characteristics of the new materials? So how we do it, we make this tea-based solution. It's a sweet tea. It's just tea and sugar. And then we grow the SCOBY. We harvest it by pulling the fabric or the cellulose off the top. We wash it and we soak it for about 3 days. And then we dry it and we look for ways to waterproof it. And at the moment, we've been looking at natural crafted ways to dry it, which includes looking at rice wraps, which I'll show you in a minute, and also looking at ways that we could waterproof it, which includes natural sorts of things like beeswax and coconut oil. And you'll see some amazing garments that our students have made that have also been coated in beeswax and coconut oil. So we've also tested the potential of different teas in Vietnam. So we've looked at black tea. It grows very well with black tea. That's our strongest material. It's very successful. Oolong tea's great. It's very expensive. And lots of herbal teas. So we've used butterfly pea tea, which is a beautiful purple colour and grows wonderful fabric. And perilla, some other local Vietnamese teas. And we've also been exploring the use of fruit and fruit waste. So one thing that hadn't been done before is generally it's grown with tea and sugar. And we were really interested in how much of the tea and sugar could we replace with food waste. So we've been feeding our bacteria and yeast with red watermelons, coconuts, red dragon fruit, white dragon fruit, mangoes, bananas. Bananas are not so good. They're more explosive, bubbly environment in the lab, which was not so popular at RMIT. And we've also tested lots of different types of sugars. White sugar is the best. It's easily digestible by the bacteria, just like it is by us. We did try cane sugar, a bit like the banana. It's a little bit too exciting for the bacteria. Grows lots of big, exciting bubbles. So it wasn't as successful. But over the course of the first year of the research, we grew over 150 samples, feeding it with all of these different ingredients and making all of these new materials. We also worked with the community in Bien Tre and in Tay Ninh. And what we really wanted to do there was to find out how they dry their rice wraps. And I think that it was because one of the things that looks really familiar in Vietnam to the gooey cellulose material when you harvest it is a rice wrap. It looks really similar, it behaves similarly. And we were putting our kombucha out on racks in the sun to dry. So it made sense to have a look at some traditional technologies that are still used here to dry rice wraps. And so these two communities worked with us for several months to dry our kombucha on the same racks that they dry their rice wraps, which was fantastic. And so it also ended up making a pattern and a print in our new materials that looks a little bit like a rice wrap. Like you might want to eat it. So over the course of the research, we've been looking at ways we can grow it. We've also been looking at ways we can test it. So we've been testing it similarly than you might test fashion materials. We've been looking at strength testing, tear testing, wear testing, like whether it's a good wearable material, waterproofing, those types of testing. And we've done some of that in Melbourne, at RMIT in Melbourne. And we also tested here in Vietnam the types of bacteria and yeast that are growing in the actual liquid and see whether that makes any difference to the outcome of the material as well. So that was new research for us. And then we've gone about evaluating the materials. We've held several panels with lots of different stakeholders from diverse backgrounds, from engineering, from fashion, from business, communication, lots of different people to come and tell us what they think about the potential of the new materials as well. So what were some of the results? The one on the far right is probably one of our most interesting ones. It used watermelon to grow, and it actually ended up making like a very thin paper-like material that was completely white. We also have ones grown with red dragon fruit. And so all of these different samples really helped us to then be able to communicate with the wider community about the potential of these materials. So from here, we've gone to working with the communities and looking at how we can engage the communities. One of the most important parts about research, apart from sharing it with all our wonderful students and inspiring them with our work, is also sharing it with the community and trying to see how we can make community impact in our community of where we live. And so that was the next stage of the project, was working with the community. So this year, we've been working in the Quang Nam province to work with the communities there, and we've been sharing all of our knowledge through open sourced workshops, and the community have been coming along and learning about how to grow their own materials in their communities, in their villages, in their eco hubs, whatever their backgrounds are, they've come along. And so they're helping us to close this loop in reducing food waste, reducing plastic pollution, and also we hope the outcome will be supporting community livelihoods in the Quang Nam province as they hopefully make the materials into new products and establish new businesses in those areas, and specifically in Hoi An, where they might make new businesses out of the materials. In a theoretical way, we're interested in this sort of sustainability orientated innovation, communities of practice and diverse economies, and what we call ecopreneurship. So that's a bit about the project that's happening now, and I think the last thing to do really is to help close that loop with why we teach about that at RMIT as well. So one of the courses that we've been using to teach about kombucha, but also about other bioplastics, so ones that are made with agar-agar or gelatin-based products. We've also been teaching in some of the more traditional technologies mixed with new technologies, so traditional wet felting and 3D shaping, so you'll see some of that out there. And also shape shifting, how we can shift the shape of the materials by heat forming it. And remind me, there's one other category out there, natural dyeing. So also looking at food waste. So the students were really inspired by the use of the food waste to feed the materials also. So you'll see some of that out there. But they've also been dyeing all of their materials using food waste. So all of our students actually bring in their food waste from home, and then they dye their new materials in the different jars of food waste. So there's some great examples of those materials out there as well. And there's some ways you can follow us on Facebook and get in contact with us and read more about our material futures research and be engaged with some of our projects. So that's us.
Thank you so much for the really interesting presentation. And when you keep talking about like trying, testing different way of growing the kombucha, I was wondering that like, is it different materials when create like different smell, different touch, and how do you feel about this?
Absolutely. Good question. And when we ran the stakeholder feedback, I think most of the thing people do is want to pick them up and smell them. And they do. They sort of sometimes still smell like sweet tea, or sometimes a little bit like beeswax. And so a nice combination of sweet tea and beeswax. But I think you're right that depending on the materials that we put into the bioplastics or we grow the biomaterials with, really changes the characteristics of the materials, and that can be the smell, but also you're right, the tactility or the textility of the materials, the way they behave, whether they look more like a leather or a paper or a plastic. Yeah.
And also, like when I was working in London, I like at 2012, 2013, there is a news that like Susan Lake was trying to make a living organism fabric, which she called bioculture, and she tried to hope that like she can make a material that in the future can make the wearer absorb vitamin from their clothes, and then after wearing, they don't need all the supplement, and then they can throw like a banana skin. And is it also working with the kombucha, or what do you?
I think that's really interesting because Susanna Lee's a founder in this area. Like she's an amazing researcher in this area, and the fact that you bring up that it was 2012, because I think it goes to show how long this type of material innovation takes to go from research in a university to making impact in our communities, and us seeing those materials out for sale, and we don't see kombucha jackets or dresses for sale yet, although Miss Vietnam did actually wear a kombucha dress last year. But I think you're right that that's one of the problems. One of the great parts about Susanna Lee's original work is she founded the idea, so when you grow the kombucha, it grows to the shape of the container. So if it's round, it grows round. If it's square, it goes square. So she was one of the people that started to look at how you could potentially have like a little gate or a fence shaped inside the container that the kombucha would grow to that shape. And so she actually grew the garments to the shape of a garment, like the shape of a bodice, and in that way it's zero waste as well, because we're going to be able to make garments that, you know, are put together from that. And there's a great example of that in one of our students' jackets on display out there, and a zero waste shape made of kombucha.
That's interesting, because now I see that there's a lot of, like, as you mentioned at the beginning, there's a lot of different type of bio leather. Like recently, there was a Vietnamese woman was founder of THיודC, which is they make leather from stream cell. That's also sourcing from Vietnam, but like their leather is so expensive and only sell for high fashion brand like Peter Do and things like this. And I was asking her the same question, like, how can a biomaterial is something that we expect to be biograde so quick, that sells so expensive? Should it be like easy accessible? Should it like used to exchange of like daily plastic or something more affordable?
I agree. I think it's one of the issues with scaling new materials, the scale of what we can grow. We can grow really big pieces of it, but scaling to manufacturing type of scaling is difficult. And I think that's where we run into issues of, you know, this actually could be a replacement for those single-use plastics, and we don't have to. We can let go of the ideas of longevity being about sustainability, because we could say, actually, this could be the 45-second bag. This could be the bag that's okay to use for 45 seconds and biodegrade, because, as you said, it could feed minerals back into the environment. So sometimes we have to have a shift in our consciousness too, because we're now trained at these ideas of longevity is what we're looking for. But in a material like this, we may be saying actually, yeah, it could be a really short time frame that we use it, and it's okay that it's going to get wet and biodegrade. But
is it what you are doing with the communities in Quang Nam and TÍCH?
Yeah, definitely. So I think that whilst productivity and manufacturing and scaling up would be all about money and making maybe making some product out of it, and at a research level, and we're really interested in how that could make impact in Vietnam, and so that's why we wanted to take it to communities and give them all of the resources and all of the tools, all of the materials to be able to grow this in their communities and their homes, in the hope that actually that might be a way in to these materials making their way to to the everyday without having to scale up and having large production houses that do that. And I think the TÍCH and the example is actually really important because scaling things in Vietnam is not an issue. I watched those wonderful women make like 1,500 rice wraps within hours, and so scaling's not an issue here. And so I think it's actually could just be the most exciting place to grow biomaterials in a community way and see that we could really get them to market quite quickly. And I hope that the ecopreneurs and the people in Vietnam take up that and run with it rather than the big business people that might want to make big factories of kombucha. I really want the small people to take up the ideas and run with them and make some money out of it and make us a better planet.
And then so when we work with the community in Quang Nam, what kind of did you, how can I say, train them to make some kind of special product or just the material itself? And then how they take up on this?
Yeah, good question. I think a little bit like tonight, I tried to keep it that the materials have so much potential. So whilst I can say to you that they might be a little leather-like or they might be a little plastic-like, and I really want them to see the materials for what they could be in their communities, what they could mean to them. We've got the most amazing group of people. We've got people that make books. I've got a young lady who has a peanut butter company, a fashion designer. They come from all really different backgrounds, and I think that that's a sort of exciting part, is that hopefully they see the potential of the materials in their communities and their livelihoods and their businesses, and also they can help to close those food waste loops or localized economies, because it may be that they team up with a cafe who has coffee waste that they could feed the materials with, and then they make a new dress out of it or whatever it is. So I'm hoping that it helps to build some of those communities.
Wow. It sounds like a very exciting future that we can have so many different biomaterials.
Yeah, definitely. And I think when you have a look at the students' work, we actually cover off 7 different techniques that they learn over the time that they're doing the course. And then they are challenged with combining 2 of the techniques. So they either have to naturally dye the kombucha if they've learnt natural dyeing in kombucha, or biomaterials in kombucha, or felting and natural dyeing. So they choose the 2 techniques that they want to combine. And in that way, it really, I guess is the same. It's getting them to be as innovative as they can with combining new and old technologies to come up with new materials.
That was great. Now I think the audience want to have questions. She was waiting for a very long time.
Sure.
Yeah.
How do we do that?
Thank you so much. That's very exciting and fantastic idea. I have 3 questions. You presented many different options for sustainable material, from algae to animal products and mushrooms, right? Different things. Why did you choose kombucha? What are the pros and cons of the materials? why is it so important that you choose this one? And second, what are the 7 techniques in growing them that you just mentioned that the students learn in the course? And say I'm a businesswoman and want to take this to the next level and make it a reality, then what are the results of the testing? What the wearing test? Is it durable? And can it sustain force against the when it's being stressed out or rubbed against other things? So where can I find the results of the testing of your studies?
Okay. Well, I've got to remember 3 questions. Okay, first question. So the first question was about why kombucha, why I was interested. I'm also interested in biomaterials and in general, so the broader area. But when I was researching in New Zealand, we did a lot of research and project work around kombucha and around bioplastics, so those 2 areas. So when I moved to Vietnam, I found that those were probably the 2 that I thought had the most potential here as well. Kombucha grows really well at 28 degrees Celsius to 34 degrees Celsius. It loves a warm environment. In New Zealand, it gets so cold, I have to use heat mats to grow it, and it takes about 4 weeks to grow a piece of fabric. In Vietnam, I don't need any heat mats. It's lovely and warm, and I can grow a piece of material in 3 to 5 days. So I think that there's a lot of positive things. You also have wonderful tea and sugar that are local to Vietnam that we don't have in New Zealand. So it seemed like a win-win situation for the research to bring it to Vietnam. Your second question was about the other techniques that the students learn. So they do change from times that we teach it, depending on what techniques are really are pushing the technological boundaries at the moment. So, but this last semester, we taught kombucha, leather, bioplastics, wool felting, shape shifting, which there's some out of there, changing the materials with the heat, shaping, natural dyeing. What other ones do we do in there? Lots and lots. Subliminal printing, lots of different technologies. But they change all the time as well. Yep. And then your third question, remind me. Oh, you're
if I
a budding
want to do a
businesswoman.
business with it, like how feasible is it? How possible it is to make a business out of it?
I guess that's where our research is at the moment. So I'm hoping that in a few months' time, I know what all these wonderful people in Quang Nam do with it, I hope. And if you are a budding businesswoman, you should definitely contact us. But what the people that are part of the project get at the moment is everything fully funded. So RMIT and CSIRO funded the project. And so they get an entire kit, a growing kit, to grow everything for the next few months. So everything is gifted to them for them to have the most success that they can in their communities, which is fantastic. I don't know the answer yet. I hope that they'll really use it in different ways and see what that is. Part of your question was around the testing of the materials. It's been amazing. It's one of the most waterproof fabrics. It's one of the most biodegradable fabrics. It's re-waterproofable like a food wrap, so you can just put more beeswax and wipe it down and put more coconut oil. So it sort of lasts as long as you need it to last. If you need it to last a long time, you can keep treating it well, and if you put it into the ground, it will biodegrade really quickly. So it's very strong. It's very waterproof, very durable. One of the things is it's normally brown, so it's got a long way to go with how we can dye it naturally or combine it with growing different materials, like the butterfly PT makes a beautiful purple leather. So I think that's where some of the innovation could come from the business people, as well as combining it with their thinking around what they could grow it with or how they could treat it, because it's a little bit brown.
Thank you.
Thanks for your questions.
Is there anyone want to ask? So like I have one more question. It's like now beside the biomaterial, we have like techwear, which is like super weatherproof, like proof everything, block tech, waterproof, windbreaker, thing like this. And do you see any of these like as the future materials? Do you see like how biomaterial compare to this kind of like super material, techwear material?
Yeah, I mean, most of the techwear materials are made of polyester. So, you know, it's one of the most damaging materials we have in our planet. So I think that working with nature on something that we grow with nature has hopefully a lot more potential than something like polyester. So I hope that, you know, in the future it can become a replacement for materials like that. But those materials also have their place in our society, and, you know, even plastic, you know, it's a great material, so don't get me wrong, although we need a replacement for it. Plastics was invented because it's strong, it's durable, it lasts for a really long time, and so if you use it for design of products or that need to last a long time and that need to be strong and durable, it's a fantastic material. It's just that we unfortunately made it into single-use plastic bags and straws without really thinking that through, and I think that is a big part about polyester because it's petroleum-based material, and so we withdraw all of the resources from the planet to make that material that we can't can't put back. And on top of that, when you wash and wear polyester clothing, it makes microplastics into our oceans, and then we know that if you eat meat, you eat the fish that's in the oceans, and the fish have microplastics, and I'm sure we've all read about the terrible nature of microplastics. So yeah, I think they've got a long way to go to compete with techwear, but and those technological fabrics, but you know, I know in my core that those technological fabrics are also so damaging for our planet. So yeah, that's our challenge. That's what we all need to work on. Yeah.
Like we have to make it become a trend, like wearing brown clothes when we are trained.
That's right. A brown kombucha jacket that you only wear for one day is okay because it's biodegradable, so you can just wear it for once and then throw it in the garden. We have to change our minds.
Yeah, please.
Hi, thank you for your information and like a great presentation. So I'm working in clothing, and that's the thing that I was thinking about when you talk about like, oh, that's a jacket and you can wear it for a day and then you can throw it in the garden and it's compostable. So I was wondering like how long could the material last, or if we have the technology or if the research have reached to a point where we could use the material for a long time rather than shorter terms, like plastic bag like. Yeah.
It does have the potential to have longevity as well. You can layer up the cellulose layers when you're drying it, and it can become a very thick leather-like material that could even be made for furnishings. It's that durable. But like a leather, you need to keep it coated and keep it supple, and you know, whether you're putting coconut oil or beeswax or worse products, but you know, something that coats it and makes it pliable and flexible and keeps it like that. So we'd also have to change our mindset about how we look after our materials. You know, we traditionally, if you bought a leather jacket, you actually had to look after it. You know, they dry out, they get creases, and they actually come apart. Leather couches do the same. So traditionally, we knew how to look after our leather materials, but we sort of lose that knowledge. So I think that's part of new materials as well, as that we need to understand how we can look after them, how long they'll last, and that's this connection between materials design and the products we design them out of, I think, and understanding that, yeah, not everything's made for a long time, and some things need to be made to last a long time. Yeah, but we're not quite there yet. Yeah, fast fashion is a big issue. Yeah.
Like, oh, okay.
How often do you have to take care of the leather products that you have tested to ensure that they can continue to be used?
At the moment, not too often, just pretty much like a leather. But what we do find is that a dry environment dries it out really quickly. So maybe again, it's about maybe we have to retrain people how to store their clothing. If you get a kombucha leather jacket, maybe you have to store it differently. So yeah, there's a long way to go, I think, to understanding how we could use the materials.
Thank you so much for this really insightful presentation today. What do you do with all the kombucha?
Good question. So at the moment we are just growing it for the materials. So we reuse the liquids and the materials to grow more materials. And the recipes we have developed are very different than kombucha recipes. So kombucha has a lot less tea and a lot less sugar. When we want to grow it for materials, we make a very sweet tea that you wouldn't want to drink. It grows a much stronger fabric. So we don't generally do that. But having said that, we are working with a kombucha manufacturer at the moment who has a lot of their SCOBY waste. So it's exactly what you would drink it from. And we're just looking at how we can use that waste, but it's not quite the same in the drying technique. So we're looking at ways we can actually mash it up in blenders and things, and what we could add to it that maybe make it into a new material. But that's very, very early stage research. But yeah, unfortunately, the kombucha process and the material process don't quite marry up. We don't get lovely drinks out of it every day at the same time.
And like how breathable the kombucha leather is.
Breathable. Yeah, I haven't really tested breathable. We've sort of tested more flexibility and things like that. But I guess that also depends on how thick you grow it. So the longer you grow it, the thicker it gets. So you can make it really paper thin, or you can make it quite thick.
Because I imagine like leather or like other polyester material, even it's thin, it's not so breathable. But this is like a living organism, so it's like I was expecting maybe it's going to be much more breathable than the other like similar localized materials.
Unfortunately, I'm sort of thinking it's a little bit more stick to your skin like at the moment. But yeah, hopefully, maybe we'll work on breathability. We could make little holes in it. Yeah.
I have a question. So actually, like I'm thinking about like how long that you can use the products. For example, like for the biomaterial, because it's biodegradable, so it's tend to that you will buy more biomaterials products. So for example, like right now, people have a chance of like using the second-hand products, and they have a lot of like second-hand clothing stores, and people try to like upcycle and recycle their product. And I think that like it doesn't matter that is like environmental friendly or not, but they still like keep using it. But like for example, like long time ago, people have so many negative comments on plastic bags, so that we change into the tote bag. But like it encourages people to like collect more tote bags. So if like you use one tote bag, so it's really good for environment. But like you have, for example, like me, I'm like victim of that consumerism. Like I have like 100 tote bags, but I think that like it's not good at all. So for example, if you create the biomaterial that will be biodegradable, so it will be like the term of the usage will be shortened. And so it is like how it's different from the like fast fashion, except like it's going, I mean, like create less waste, but actually like increase the habits of consumer.
I agree, and I think that's what we were touching on before, as well as that actually sometimes these materials might actually have to also have a change in mindset. That change in mindset for consumers for, the last 10 to 15 years has been, drumming into people about reusing their materials and not buying new things, and the longevity of how long we wear something or use tote bags or... So it may mean that with biomaterials that we do have to rethink again, because they might not last as long, or we might actually want to decompose them quicker. We might want to have materials that we only use once. So I think that that may be a little bit more change for consumers to have to contend with. But I think that's also a good thing, because there's only really a certain part of consumers that are carrying or owning tote bags at all, let alone 100 tote bags. So that means that, somewhere along the line we've done a great job, but there's also a lot of mass consumption that isn't buying in those ways still. So, yeah, a challenge.
In the classes, the experiments, or in the projects you've done in Quảng Nam and Bến Tre and Tây Ninh, is there any measurement of how much it costs to produce how much?
That's a good question. It was actually a question that came up in the community workshops as well. We haven't really done that because there's so many different materials we're using to feed the materials. So in theory, there's really no cost if you grow it outside in the warm in Vietnam and you're feeding it food waste. There's just your time and energy, really. So very, very little cost. Where the costs come in is if you feed it with teas and sugars, then you've got those costs. But again, they're ingredients that are a lot more accessible and a lot cheaper in Vietnam than in other countries. So we grow that here. So I think that all of the materials are local, and I think that makes it more economical. But we haven't worked out a per sheet cost.
Has there been any experiments with mixing other things into the process of it forming the layer, not after?
Mm-hmm. And the students have done some of that. So part of the process was like what they could feed it or other materials that they could grow it with, because they had the challenge of combining two different technologies or materials. So they definitely have. They've tried putting different materials inside the liquid as well and growing the SCOBY around that. And that's a potential new material, because it could be that it grows around cotton or wool or something like that. But of course, then once you make materials that have a more than mono material, where they're a laminate of two materials, you could come at risk of them not biodegrading in the same way, or damaging in different ways. But again, it's such an interesting part of the future of the research, is those types of combinations and combinations of technologies moving forward. Yeah.
Yeah, I think you can also go to see the student work later as well.
Hi. So I am a student from RMIT, and I'm very happy to be here. And first of all, I am very grateful that you find the urge and you are willing to dedicate your time and ability to serve the environment and serve the environment, especially in Vietnam. And I'm very grateful for it. So thank you very much. And I think it is a very promising project. And so I just have a few questions. So do you think that in the future, in the process of making it known and used to the mass, will you have to sacrifice in some way to make it be able to mass produce and then not very biodegradable anymore? Will that happen? And that is the first question. And secondly, is there other applications to this other than fabric and clothing?
Yeah, great questions. I think in scaling up, it shouldn't incur any more processes that wouldn't make it biodegradable. Because it grows to the size of the container, You just scale it up to a paddling pool size or however big you want it, and it grows to those sheets. The difficulty maybe would be that then you've got to still wash it and soak it and then dry it. So, but you know, there's like in the example with tannin and things, you know, you can dry them out in the sunlight, and so there's a lot of natural processes we can do. So I think that the scaling up has, if put in the wrong hands and is with big commercial partners, perhaps could be more damaging if they, you know, build big heating mats and big warehouses that grow it. Sure, you know, it could have the potential to do that. So I hope that being in the community level, we can see some of that ecopreneurship of the Vietnamese people being able to, you know, make 1,500 rice wraps in a day, which. So I think that there's a big opportunity there for that. And what was the second part of your question?
Are there any other applications?
Sorry. Yes, definitely. I think in terms of food wraps and food packaging, it has a huge potential because it's quite waterproof. You can fold it up and it stays in the way you folded it. So it could wrap sandwiches or banh mi or something like that really, really well. And of course, it's completely edible. You could feed it to your dog or eat it yourself. So it's, you know, it's a great way to have a food packaging as well. So I think it would have potential there. I think other potentials here would be in replacement for some of our leather products like handbags, bags, shoes, those types of things that probably has a big potential in those areas as well. But I sort of enjoy the fact that I think it's limitless potential, and so depending on what you do with it or how you grow it or what you feed it, or it's sort of limitless. And so I like the fact that it could have potential in so many different applications. Yeah. And if you're a student at RMIT, the course is also a general elective. So you can take the course. Yay.
Thank you so much.
Yeah, so I think we have time for one last question.
Yes, my question also related to scale up. So maybe I think the challenge in the scale up is about the consistency. So do you think you can give some certain formula or just the idea for the community to develop their own?
Yeah, I think it is about scalability, and if you read about it and why Susanna Lee's research from 2012 hasn't gone very far in that regard is because of scalability. But I think that what we did do is we developed a recipe book. So in making lots and lots of the materials at RMIT in a lab, we were able to make those processes familiar. The quantities were the same, the temperature that we grew it in were the same, the solutions that we grow it in are the same. And so I think once you can get some of those things and you can give those to the communities, then they'll have a lot more success. That one of the biggest challenges at the beginning was just getting it to grow without having mold on it, and learning when to harvest it. So there's so many challenges. So I think that developing the resources and the toolkits and the growing kits for them as well has given them a big leg up in that area, that they can just get in there and make it and know that our recipes have been tried and tested and work, and then that way they can really work on the challenges of how they can grow it in their communities, whether that's their back gardens or they make small growing areas, or So I hope we've given them enough resources for them to be able to make a good start with that.
So, yeah, thank you so much for coming to the talk today. Thank you for your presentation. And then also we have the work of the student on the other side, along with other artists' work. So please come and take a look.
Yeah, come and check out all the exciting materials. Thank you so much.